All right, this is section 3.2, measures of variation. We've got lots of notation, lots of terms going on here, lots of formulas, calculator stuff, so make sure to be ready to take lots of notes and pause the video often. Measures of variation, we're going to be talking about the range, the standard deviation, and variance. And we're not just going to find them, we're going to interpret and understand them. Here is the main vocabulary and important terms we'll be talking about. So let's look at the basic concepts of variation. We just want to be really mindful when we're rounding these. Carry one more decimal place than is present in the original set of data. Not a huge deal, but just something to be mindful of. So the range, y'all have been seeing the range for a very long time. The range is the maximum data value minus the minimum data value. It's not resistant because remember, if we have a really large maximum or a really small minimum, it's going to be very sensitive. So we call this not resistant. Example 1, finding the range here, we would just find the maximum value, subtract the minimum value, and that would be our range. Now, something that may be new to you is the standard deviation of a sample. The standard deviation measures how much data values deviate away from the mean, so differ or move away from the mean. So we're going to use lowercase s for sample and lowercase sigma for population. Remember, Greek for population, English for sample. So what's important about this? It's a measure of how far the data is away from the mean. I can't say that enough. We're calculating the distance from that arithmetic mean. And the value of the standard deviation is never negative, and it's only 0 when all the data values are exactly the same, which means the data never varies from the mean because it's all the same. Larger values of the deviation indicate greater amounts of variation, which makes sense. If you've got really big data variation, you're going to have a large standard deviation. The standard deviation can increase dramatically with one or more outliers. It can be really affected by those extreme values. All right, so this is a crazy formula. We're going to go through it. We're going to make a table just like we did when we found the mean of a frequency distribution, and I promise I will show you how to put this in the calculator at the end. So to calculate the standard deviation of a sample, we're going to break it down. First, we're going to find the mean, x bar, so that's right there. Then we're going to subtract the mean from the individual sample. So each data value, we're going to subtract the mean, which makes sense. We're trying to find the distance. Then we're going to square the result of that, which is this. Then we're going to add up all those answers, which is the sum, the sigma. Then we're going to divide the total by n minus 1, or the number of data values, subtract 1. Excuse me, my dog is coughing up a hairball, if you can hear that, sorry. And then find the square root of your results. So we are going to do it by hand, and then at the end of the section, and probably in part 2, I will show you the calculator. So use sample standard deviation formula to find the standard deviation of these data values. So I am going to build a table. So remember, we're trying to get to this formula here. So what I need is the x bar, and then I'm going to subtract each value from, I'm going to subtract the mean from each value, then I'm going to square the result, then I'm going to find the sum of that. Then I'm going to divide that by n minus 1 and then square root it. And that's how I'm going to get it. So what is the mean of all this? So to calculate the mean, I add it all up and divide by the total number of numbers. So I get 30.74. So then I'm going to go through and subtract each one. So I get 7.76, 24.86, negative 8.34, negative 16.64, negative 7.64. Then I'm going to square. And if I'm going to be honest with you guys, how I actually calculate is I go across, because in my calculator I get the result and then I just square it right away. I find that actually a little bit easier. But whatever works for you. So I'm squaring this previous column. Be careful with the negatives here. Then I'm going to add up. That's what the sum means. I'm going to add up this whole column here. And I get this number here. And then I'm going to move it over to this here. I'm going to take that number and divide by n minus 1. N is 1, 2, 3, 4, 5. So n minus 1 is 4. And I get 270.26. Then I'm going to square root that number. And I get about 16.44. So the standard deviation is 16.44. go ahead and give this one a try. And then see, what do the results mean? What does the answer mean? So that's the standard deviation. The results don't mean anything again because they're Jersey numbers. I mean, maybe if the mean made sense, then the deviation away from the mean would make sense. But because the mean is meaningless, it doesn't make sense. When we calculate it for a population, it's the only difference mainly is we're just dividing by n, the actual number of people, not n minus 1. And that's pretty much it. Okay, so this is important. Range rule of thumb for understanding standard deviation. The range rule of thumb, but it's a simple tool that says the vast majority, 95% of sample values lie within 2 standard deviations of the mean. So significantly low values, mu is mean, remember, and sigma is standard deviation. And so when we say mu minus 2 standard deviations, so the mean, 2 standard deviations less than the mean and 2 standard deviations more than the mean. So values aren't significant in here, which kind of makes sense. That's just, they wouldn't be outliers. They would kind of fall within close to the mean. Let's do an example. So using the 50 Verizon data speeds, the mean is 17.60 and the standard deviation is 16.0. So that means that the mean average speed is, I said average and I said we weren't going to use that word. The mean is 17.6 and the standard deviation 16 on either side is the standard deviation away from the actual mean. So use the range rule of thumb to determine if they're significantly low or significantly high. Find those ranges and then determine whether this is significantly high. So significantly low, if we go back, significantly low is the mean minus 2 standard deviations. So the mean is 17.60 minus 2 standard deviations. And significantly high is the mean plus 2 standard deviations. So 17.60 plus 2 standard deviations. So when I get those values, I get negative 14.4. That would really deviate from 17. And then 49.6. So is 77.8 significantly high? Yeah, it is. If the mean is right here and we're saying it's significantly low this way and significantly high this way, 77.8 is significantly high. If you want to see that kind of worked out another way, there's the solution. Go ahead and give this one a try. And there's the solution. There's a range rule of thumb for estimating a value of the standard deviation S, and that is basically to say we can approximate the standard deviation by taking the range and dividing by 4. So the range rule of thumb, if we want to estimate the standard deviation, so if we know that we've got the minimum and the maximum, so that range would be the max minus the min, and then we could divide it by 4, we would see we get 19.25 as the standard deviation. And so we could estimate it that way, but we know that the actual value is this. So it's in the neighborhood, but it's not a perfect measure. You can go ahead and give this one a try. And here's the solution. So variance is another measure of variation, and it's the square of the standard deviation. So if you have the standard deviation and you square it, you get your variance. So again, S is sample standard deviation, square it, and you get the variance. We don't really use the variance as often. We really use the standard deviation and the range more, but it's good to know what the variance is and how to get it. And that concludes part 1 of section 3.2. Be sure to continue on to part to see beyond the basics of variation and a couple really important big key ideas for our statistics class.